Hi, dear student. I just wanted to start this class with a small question. So, I gave you a cup of tea. You have tasted it and you felt it is stronger. You don't like a stronger coffee. So, what you do is you will add a hot water. And after adding the hot water, you have tasted the coffee and you felt it is lighter. Now, the question is, my dear students, what happens? Did we remove the coffee content or did we have just made the coffee content to be reduced? No, my dear students, there is something happened. That means the concentration has been changed. The first coffee, that means the coffee which I gave to you, was little slightly stronger side. That means the concentration was higher. Now, as soon as if you add the hot water, what happens? The concentration has been reduced. Now, my dear students, the change in concentration is called as what is that? That is dilution. My dear students, so usually this is what happens in the chemist. So today I just wanted to talk about something called as the normality and the dilution. So the topic that we are going to talk today is normality and dilution. So, my dear students, we just now spoke about what is dilution. That is the change in the concentration of the solutions. So, this is what happens. Now, let me go with another one more examples to make you more easy to understand. So, my dear students, imagine there is a beaker, okay, in which it has 100 ml of 2 normality of HCl. Okay, so assume this is an HCl of 2 normality. Now what I did is I just have added water. I have added water. Now what happens here? Look here. Now, my dear students, you can observe that there is a change. What change can you observe, my dear students? What can be changed will be observed. So, did I add the acid? Did I add the acid? No. Did I reduce the acid? No. No, what remained constant here? What has been changed? Now look at here. Now look at here. I say the change is happened in volume. Is that correct? Because initially it was 100 ml. After adding water, there is a change in volume. And the next thing, what remained constant? What remained constant, my dear students? Now, my dear student, this is very important. What remained constant, my dear students? What remained constant? It is the amount of acid. So the amount of acid is remained constant. The amount of acid is remained constant. We can observe the change in the volume. Now coming to quickly, now what is this normality is? Now my dear students, what is this normality? So normality is nothing but it simply tells us how many equivalents how many equivalents are present in 1 liter of solution. Are you clear? What is this normality? So it tells us the information. What is that? That means how many equivalents, how many the content is present in 1 liter of solution. My dear students, make a note here that is higher normality. Higher normality means more equivalent packed in 1 liter. Is that correct? So if more equivalent is present in 1 liter, that means it is highly concentrated. That means it is having more normality. Now, lower normality means what? Now look at here. Same equivalent spread throughout a large volume. What I want to say is, So the same content of HCl was spread throughout the volume. Volume has been increased. That means the initial normality of HCl will be changed. Now, my dear students, now how do we identify this? How can we find this? So to find this, we need to have the formula of normality. Now, my dear students, look out here. I'm here with your clear explanations. So before dilution, what happens before dilution? That means equivalence is equals to normality into volume. Is that correct? Before adding water, equivalence is equal to the normality and the volume. Now, after dilution, that means after adding the water, what happens, my dear students? Volume has been changed. Is that correct? Volume has changed. Is that correct? Yes, dear students, volume has been increased. Next, what are the changes you can observe? Normality is also changed. Okay, normality is also changed. But here, what is the constant thing? But what is the constant thing? Number of equivalent, number of equivalent remains, it remains unchanged. Is that correct, dear students? The number of equivalents which is present in the solutions, it remains unchanged. Equivalent, therefore equivalent before is equals to equivalent after. All right. So that means I will derive with the formula that is N1 V1 is equals to N2 V2. Are you clear, dear students? This is how we can derive. This is how we can derive. This is a formula to be derived. So my dear students, now let us have one small question. Now I have, just a second. Now I have 100 ml of 2NHCl. So I want 0.5 N of HCl. Now, how much of water is required? Now, this is the question. Okay. Now, see, it is very simple, my dear students. Now, with the formula N1 V1 is equals to N2 V2. Now, what is the N1 here? N1 normality is given as 2. That means 2N of HCl. And what is the volume of the first measured solution is? It is 100 ml. Now we have N2 that is also given, that is 0.5. And what is the V2? That we have to find out, my dear students. So substituting these values, we can say that 2 into 100 that is equals to 0.5 into question mark. That is the V2. So I'm going with this. V2 is equals to 200 by 0.5. That means how much, my dear students? It is 400 M. So that is the V2 is 400 ml. Now what you have changed, what you have observed, initial is equals to, it was 100 ml, right? Now final, it is 400 ml. Now what is the difference? How much of volume out is increased? That is 400 ml minus 100. That is equals to 300 ml water is required to get what? 0.5 NHCl. So my dear student, this is how we'll bring out, right? So it is how we will bring out the question. So my dear students, I just wanted to summarize this. What we have learned, what we have learned, what we have learned, my dear students. Very simple. We have learned dilution. Dilution changes concentration. Is that correct? Dilution changes concentration, and normality will measure concentration. Okay, normality will measure concentration. And remember always, Always equivalence remains unchanged and hence N1 V1 is equals to N2 V2. So since number of equivalents remains constant, so the volume N1 V1 is equals to N2 V2. So I hope that is clear to you, my dear students. So I hope you have understood the normality. Thank you.